In this video that I already shared about factoring quadratics with other leading coefficients, I shared two strategies, one being factoring by grouping and one factoring by trial and error. So one thing I did want to add, I talked about using compatible numbers to factor by grouping, and there is a strategy here that I forgot to share in the video. So when this coefficient in front of our square term is not 1, right? This is not 1 anymore, like our prior video, 2 prior videos ago. It helps to split this term into 2 terms that are compatible with 2 and 10. But if you're struggling figuring out, well, how do I know how to split 9 up? Do I split it up into 1 and 8, 2 and 7, 3 and 6, etc., right? What we really want here is we want to break up 9z into 2 terms that when multiplied give us 20, but when added give us 9. Okay, when multiplied give us 20, but when added give us 9. So if we look at that, if we look at factors of 20, we have 1 times 20, right? 2 times 10. Oops, 3 does not go into 20. 4 times 5. And then right here we see 4 times 5, that can give us 9. So that can help us pick those compatible numbers. So I apologize for not sharing it during that first video. So just to finish this question out here, between 4 and 5, I want to split this 9z into 4z and 5z. And they're both positive because I have a positive 9. So I'm just going to bring my 2z squared down and my 10 down. And now of these first 2 terms, I want to ask myself, what's my greatest common factor that I can factor out here? And that would be 2z. So I'm left with a z plus 2. Now if I look at the next set, positive 5z and 10, I can factor out a 5. Oops. And to get 5z plus 10 back, I would also get z plus 2, which that's a good check, right? That's how you know you're doing it right. So this factor is similar. So I would have z plus 2. And then the other factors, this 2z plus 5. And like I stated in the other video, it does not matter which factor comes first. So if you entered 2z plus, or wrote down 2z plus 5 times z plus 2, these are interchangeable because multiplication is commutative. Right? Let's look at this next one, 3h squared plus 10h plus 7. So again, to help us think of those compatible numbers, I want my factors of 21 that add to 10. So I have 1 and 21 and 3 and 7. So I can split that 10h into 3h and 7h. So if I just rewrote this, I have 3h squared plus 3h plus 7h. 3h plus 7h is the same thing as 10h, right? And just bring down my 7. Now my first 2 terms, I could factor out a 3h. I get h plus 1. And my last 2 terms here, 7h plus 7, I can factor out a 7. And I get h plus 1. So awesome, I know I did it right. Because now I have 3h plus 7 times h plus 1. Right? Those are common among both there. So this final trinomial factored would be 3h plus 7 times h plus 1. I hope that clears up choosing those compatible numbers. I apologize for missing that in the first video. Hope that helps.